Bronco Lesson Chat. Do you hear my audio, and does it sound super messed up to you? Sounds like an evil robot. Gosh, I hate to debug this on stream. What's going on over here? Yeah, looks messed up over there. Let me kill my audio engine and restart it. There we go. Okay. So the audio routing on my streaming setup is pretty complicated and very low latency. So if something goes wrong, I'll start just getting buffer underruns and things will go crazy. Well, let's start over. My name is Brian. Welcome to the stream. I'm going to do some hacking on the Tiger Beetle Rust client. Tiger Beetle is a high-performance financial database written in Zig, and it has clients written in a number of languages, including Python, Java, Go. Does not have one in Rust. So I'm doing a project on this stream over the course of many weeks to build the Rust client for Tiger Beetle. The whole project is on stream, so if you follow from front to back, you'll see developing of a modest Rust project all the way through, warts and all. It's a pretty good project for instruction, though, because it's got FFI topics, async topics, performance testing, a lot of typical Rusty subjects in this project. So today, we're kind of at a point where we're kind of creating a lot of clear air for ourselves. We solved a lot of the problems. Previously, we've been working on just kind of understanding how the underlying client library works. The Rust client is actually bindings to a library called TB client written in Zig that exposes a CFFI. And same for all of the Tiger Beetle clients. They're all just bindings to one library that has all the real client logic in it. And so we've been kind of understanding how the client library works, the TB client library, and figuring out how to layer our idiomatic Rust abstractions on top of it. So far, we have implemented 2 of the requests out of 9 requests that Tiger Beetle supports. And we've iterated on those 2 requests for a number of hours now, a number of streams. And we've kind of gotten an API that looks idiomatic and we're kind of happy with and think we can live with and develop. This API, looks good on the outside. On the inside, it's very allocation heavy. So performance-wise, there's a lot to be desired, but we can think of optimizing that later. Let's get everything working first. And so last time we just did a bunch of cleanup on our API service to making the API look really good. And so we're kind of happy with how the code looks. And so today, I just want to push ahead and try to implement a few more of those request types. And it should be just a matter of kind of duplicating the work we've already got. And we've already in a very good place with the requests we've implemented. So it should just be like those same patterns we've already done twice, but with a few variations for the other requests. Should be a pretty chill, easy stream. Hey, Billy Harrington. Welcome to the Tiger Beetle stream. Tiger Beetle, of course, is written in Zig. If you're expecting Zig, we're doing Rust today. But sometimes this stream has Zig on it. Let's go ahead and figure out where we were with the code. So let's go over to the code again. And remember, I often forget to show you the code in OBS. You'll often be staring at the wrong screen while I'm coding. Let me know if you're not seeing what I'm talking about. So here's our Tiger Beetle Git repo here. And the first thing I do every time I sit down is kind of refresh where we were last time. Hey, Billy, you're here for Rust? Great. I got Rust. There's a lot of Rust on this stream, and I know Rust pretty well. Although I make a lot of mistakes on stream, and I also forget a lot. I'm getting old. So I often find on these streams that chat has to help me quite a lot, even though I'm nominally a Rust expert. So the first thing I usually do when I sit back down to a project, and it's been about a week now, is just kind of like get the build going again and refresh my memory of where we were. So here's our branch, and you can see we're on the Rust client branch. My history here is just nonsense at the moment, which is fine. I don't care about history right now. And I'm not going to rebase this time because I just don't want to deal with that. I know there's not going to be any conflicts. So I'm going to go ahead and build the C library because, again, our client library is bindings to a C/Zig library. And to do that, we need to do a custom Tiger Beetle build command. Eventually, the whole build system will be kind of linked together, the Zig build plus the Rust build, but right now they're two separate things. So we always got to go build the C library first. And then let's dip into our clients, our Rust client here. Let's see what we got here. And we can just do a check and build. I always kind of prime the workspace for both type checking and building. This is a cargo build, not check build. It gets all the dependencies kind of built, so we won't have to rebuild the dependencies once they're in the flow. And I'm going to go ahead and run our program. We have a little test program that is not unit tests or anything, but they're just kind of like manual tests for, checking our program as we go. A lot of our work here just involves running the Rust type checker for hours at a time. And then we kind of do like a smoke test that it actually runs and doesn't crash or panic, doesn't ever like literally crash because it's Rust. But so we don't really have any tests here to test that our stuff works. We just kind of manually test every once in a while at this phase. So let's look at our code here. What is going on? I must have opened the wrong thing. Yeah, clients, Rust. And here we have our library and also our main function. This is like a separate little test harness we got. So in our tests, we're creating accounts here, and we're then looking up some accounts. And we can run this, cargo run, and this is not going to work because we have no server running right now. So again, getting our test environment set up involves getting our server running again. And so we're going to say zig run. And this is just running Tiger Beetle, and start is the command to start the server, and that is build run. Zig build runs your Zig build script, and then your build script can just do whatever it wants. It's not like Rust. In Rust, most of the build is declarative, but in Zig, most of the build is imperative. It's got a mix, of course, but it starts off as just a main function, just do anything you want. So we have to pass addresses. Now Tiger Beetle just telling me what I'm missing on the command line. Addresses is 120.110, and the path to our test database is right there. It's ready to go. Now we can run our bindings test, and it does, something good enough for now. So let's look at our library. And the last time we spent just a while just cleaning this up and making sure we were happy with everything. And just to refresh our memory, I'll walk through it here. We're doing heavy development now, so I've got allow unused on here so we're not annoyed by warnings all the time. These are all our imports. These are the generated Rust bindings to the TB client C API. And that's why there's a bunch of lints allowed on here, because this module in Rust doesn't look like Rust. It looks like C written in Rust. We can open that right now. You can see this is generated by Rust BindGen as part of our build script. And this has just got a bunch of spew in it that is all of the underlying C API. This is generated from tbclient.h. This header file is the API surface for the underlying TB client library, also auto-generated from Zig. So there's several layers of just code generating code here. And we're going to have to cross-reference these files a few times to understand what the new requests are like. But let's go back here real quick and continue looking at our code. This is the client type. It holds a opaque inner client type. Our constructor, not anything really special about this. This is not entirely complete yet. There's other options you might want to pass in initializing the client, but for now it doesn't matter too much. This is one of our requests, create account. You can see it's an async API. We're returning futures. So everything's going to be async REST. And we spent several episodes trying to write this function as a async function and discovered we couldn't control our lifetime captures very well when we did that. We spent a lot of time just refreshing ourselves on async REST programming during this stream. And you can see all of our requests. You can actually pass kind of per message to the server, you can pass multiple requests of the same type. So all of our request methods are going to accept a slice of what the Tiger Beetle client calls events. And each one of these is essentially a single request, but they're all batched up together. And that's for efficiency reasons. And then, this method is pretty simple. The last time this used to have a whole bunch of open-coded, unsafe code that was duplicated between all of our requests. In the last stream, we cleaned this up into, I'll show you on the other window, this create packet is doing a bunch of work to create the underlying data structures that the TB client library needs. And then collect results is doing a bunch of request specific work to convert the underlying C results into suitable REST results. Again, you can see here inputs, there's a slice of inputs, a slice of requests, and the outputs is a vector of results. And they're one-to-one. Go look at the create packet down here on the right side of the screen. This, we spent a number of episodes just figuring out how to get all this working. And then we copy and pasted it between two different request methods, and then we factored it out into just a helper function. You can see it's generic on several type inputs here, type variables. These are the event types, which we saw here. Account is an event. So REST event is an account in that case. And it's generic over the output types, and there's some constraints over the generics to let the implementation, do things like copy values or convert values. And this unsafe code is super fiddly, and we made a bunch of mistakes when we were copying and pasting it around. So having it all in one place as we implement more and more requests is going to be very helpful. Give us confidence that we haven't made, crash bugs, because there's so much unsafe code here. And crashes are a real possibility. And then here's our other generic method that we've made last time. And this one I am less happy with, collect results, because as you can see, the method signature here is a real mouthful. This is tough to read. If you go slow, you can understand what it all does. And I've given as expressive names as I can to all these type parameters. But this is pretty ugly. Still, pretty nice that you can factor all this out. And that's for this final step of the request. And so here's our account lookup request. It's a second request. And so today we're going to implement more of these requests. It's going to be hopefully pretty laid back and not have a lot of challenges. Should just be understanding what the data types are, doing some copy paste, changing a few generic type parameters and things like that. So on the right-hand pane here, I'm going to go look for more requests to implement. And I think to do that, I'm going to look in Tiger Beetle's state machine. And Tiger Beetle, the state machine, is kind of like the core data structures of the entire database. And Tiger Beetle's abstractions are pretty flat. So what you see in the state machine tends to be exposed, in multiple layers of the stack, even in the client. And so these requests that we're implementing are called operations. There's a few different terms in Tiger Beetle that are all related, but operation is what the state machine calls them. If we just go look for code related to operations, I'm going to search for a capital operation. So here's the enum that represents all the operations. This pulse is kind of like an internal detail. I don't think we need to care about it. But we've implemented create accounts and lookup accounts. So the obvious next steps for us are probably to do create transfer and lookup transfers. These should be substantially similar to the requests we've already done. And the main thing we need to understand to do this is to understand what the input types are and the output types are, which we have output type is down here, like create account, it's create account result. And we have Rust redefinitions of the C types. But we need to understand there's some input type and some output type for all these. So let's focus on create accounts. And I'm just going to go ahead and just stub a method for this request based on submit create account. I mean, we're going to do create transfers, not create accounts. Sorry. This create account. I'm going to just copy paste this for now. And we're going to say, keep them in the same order as declared in the state machine. So after create account, we're going to say, and I'm just seeing chat, this operation is called create accounts. And my method is called create account, but my method submits multiple accounts. So this is not named correctly. I'm just going to put a to-do there. I don't want to yak shave too much. Wow, now it's gonna bother me. We can rename this correctly for real fast. This is going to be submit create accounts. This is going to be submit account lookup. Well, it was actually called lookup accounts in the state machine. All right, forget all that. We're going to revisit this some other time. For now, it's called create account. And let's go put it after. I'm going to put create transfers after create account. And I'm going to complete this method, and I'm going to just stub it out and put a to do here. Because this is a future, I have to put this in an async block or it won't type check, I think. I'm always forgetting exactly. But I think I need to put this in an async block to make this panic type check. And this is called submit create transfers. Transfer. I'm going to keep it consistent with my other method, even though the pluralization is wrong. In this event, I don't know what this is. I'll figure that out in a minute. I'm betting it's called transfer, though, based on the pattern we saw in the other method. And then this result is going to be create transfer, okay. And that's my own type that is defined down here. So I'm going to follow this pattern and say create account, okay, is going to return a create transfer, okay. And then I'm guessing there's probably some kind of corresponding set of error codes specifically for create transfers. So I'm going to go ahead and duplicate this as well and say create transfer result. And then I'm not going to fill out this enum yet, but I'm just going to put one in here as a placeholder. So we have a create transfer result. And this should be enough to type check that method stub right here. So I'm going to say cargo check. And everything checks. I'm going to checkpoint my commit. Now I want to find out what this event type is for create transfer. And I think there's another method over here in the state machine. I'll make sure you can see it on your screen. This event type, like this is it. This is exactly it. This is our input events for a particular operation, and these are the results for an operation. So you can see for create transfers, it's a transfer type, and for the result, it's a create transfers result. So that's pretty easy. So I'm going to go ahead and find this transfer type, and I'm not going to bother looking at the Zig type. I'm just going to go look in the Rust bindings, I think. If I look for TB client transfer, not TB client transfer, just TB transfer. There it is. Here's the C definition, or the Rust definition of the C definition of the Zig definition of the transfer struct. And these all share the exact same representation, so they're all just the same types. But I need one that looks like a Rust struct. This is a Rust struct, but it looks like a C struct. So I'm redefining all these. Yeah, Langception here is that tends to happen with FFI code. You have like a lot of very thin layers of abstraction, all kind of like being very protective of each other, like keeping each other at arm's length, which is good. Like FFI is so complicated. You want to do like a little thing at every layer. So for our transfer type, we're going to create a transfer struct. So this event is going to be a transfer. I'm going to go look at our account struct down here that we already have. And we're going to go create a transfer struct. So again, the Rust API, we're handwriting all this stuff. You could have some scheme to kind of auto-generate this stuff, but auto-generated code looks like this ugly code on the right. In general, at the very top Chrome layer of my Rust APIs, I'm handwriting everything. So there is a lot of duplication. You can see these conversion functions down here are just like, this is all just hand-maintained. And probably at some point when we start testing this code, we'll write some tests that introspect the C code and the Rust code and ensure that, for example, this conversion function is right and stays right in the future. But the top layer of the API is almost always completely handwritten by in my preferences. All right, so our transfer type, let's go ahead and this is called transfer, not account. And we can just copy these fields and mess with the types just slightly. You can see the bindings for C call this ugly type. But we can just call it a U128 because they're the same thing. And this will look like Rust in the documentation, not like a amalgamation of Rust and C. And then I think debug copy clones are okay. And in the Rust code, we don't care about the representation. We want Rust representation. So this all looks okay. You can see I put some to-dos up here on these fields of account. I'm going to go ahead and put to-dos as well down here because as flags, if we think about our ergonomic Rust API, just having bit flags as a raw integer type and doing bit math with flag constants is not very Rusty. So we might want to think harder about how we're presenting these flags, make them some other more ergonomic Rust type. But I'm punting that. That's not a big deal. It's probably a far future thing. And then the timestamp again, I don't understand yet what this timestamp represents or what it's for. Like if it's something that the user needs to care about in physical time, then U64 is probably not the right Rust type for it. But if it's just logical time used by the server to keep pace, then who cares what type it is? So got some to-dos there. All right, there's our transfer type. And I think this should type check still. We haven't actually used that type for anything significant. And these conversion functions are pretty boring, so I'm only going to implement those once the compiler complains and says we need them. Then this create account, create transfer. We should just be able to copy and paste this body and then do some replacement of type parameters, and it should work. So here's a submit account lookup. So we replace this. Now this. So before, this was a lot more complicated before I extracted those generics, but now it should just be a matter of like scanning this and replacing a few types. So this is create packet 128, submit create transfers. Where did I copy this from? Oh, I'm looking at the wrong code. Ooh. We're working at create transfers. So this is a transfer and a TB transfer T. You can see this is just for doing the conversion between them. And this operation is not create accounts, it's create transfers. And this TB client submit is exactly the same. And then collect results. This is going to be slightly different. So here we have create account OK. This function is very complicated, so I'll go show it again on the screen and explain what it's doing. Collect results. All right, so This first one is just the message we've received back from the other thread. The way the TB client works is we submit on the main thread our requests, then TB client goes off onto some other thread and does the work so that the main thread can keep spinning in whatever event loop the bindings language cares about. But the actual work of the underlying client library happens on some other thread. And then it's going to send us a callback on that other thread. So the work is done on some other thread, and the callback for completing the work is called on another thread, an arbitrary thread that our original event loop doesn't know anything about. So what we do is we use a Rust message to send the results immediately back to the original main thread. So obviously there's a lot of inefficiencies there that we could think about getting rid of in a pure Rust client library. But every request submitted involves going back and forth between two different threads. So this message is used to get the information back onto the main thread again. This closure here is for determining whether one of the results is related to one of the input events. Because Tiger Beetle prefers, when it can, to send no results. Remember, every message we send to Tiger Beetle is a list of events of a single operation. And then if it can, and then Tiger Beetle has to send us back a list of results. But some of those results are just empty results for optimization purposes, so it's sending less data in reply. And so in order to interpret our list of results and list of events, we have to do like a parallel iteration over the results and over the events at the same time and figure out for every single result, does this result correspond to this event or not? Because sometimes there just won't be results. A lot of times there just won't be a result. And these generics are dealing with that. So this first closure is like, given a result, an event, is this result for the event? And that's different per operation. And this next one is actually a function. You can see here, actually not a function. This one, create account success, this is just a value that's going to be copied. So if there is no result, this is kind of like the return value of no result. And for create accounts and create transfers, if the server says nothing about the request, that means it succeeded. So this is just a value here, empty result, to be copied in the case that there's no result returned by the server. This next one is actually a function to interpret the result when we do get a result back. And in the case of create transfers, if the server tells us anything about the request, that means the request failed. And so this error is, this is a variant of the create account. Hold on, I got a bunch of white space here. Let's get rid of that white space. This is a variant of create account OK enum, but this create account OK enum contains value there. And so it's both a variant and a function. So we're actually passing this function called create account OK error here, right here in this type parameter, or this non-empty result parameter of collect results. It's a function that interprets the result of the request into, in this case, a create account OK. So the thing we really need to do here then is figure out what the case is, how we correlate the results of create transfer to the create transfer events. And this is probably exactly like this, but let's go ahead and look at our bindings again for probably, okay, this is definitely not going to be create accounts result. This is going to be create transfers result. And you can see I'm not typing any type parameters here. Again, if we go back and look at our collect results function, this is a very generic function, but over here we haven't given any of the types for the generics. They're all inferred. So here we're typing create transfers result here in this closure argument, and this is inferring out to the collect results arguments, type arguments. So this is probably a create transfers result, and this is a TB transfer T here. And if we go to our bindings and we look for TB create transfers result, This is very similar to the create accounts result from the other method. We have an index, and that index is an index into the original event array. So this code should be exactly the same. This code should be exactly the same. Now, if we build this, it's not going to compile because of missing implementations of traits. So this collect results method function here, generic, it requires some of these generic type parameters. Let me make sure you can see this on your screen. It requires some constraints on these generic type parameters in order to implement the function. Like the result type has to be copy. We've probably already done that because we derived copy on the structs that we created. Rust result has to have an implementation of from C result. So we have to be able to create a Rust result from C result. That's probably the big thing we're missing right now. And I'll go ahead and run the compiler and let the compiler tell us. The compiler is very good at telling us the next thing to do. And I have made some typos and such. This is just a typo here for the first one. So we go look at line 99. This is not a TB transfef, it's a transfer. I'll keep having the compiler tell us what's next. TB trans, did I typo this twice? I did typo it twice. It's not a transfer, it's a transfer. We'll keep getting the compiler to tell us what to do. And all right, now here we go. It's saying here, create packet. We're trying to call create packet, but we don't have an implementation of from transfer for TB transfer T. So that's one thing we have to implement. And same thing down here. We don't have a from TB create transfers result T for create account result. And down here, it looks like we did a typo. It's expecting this, but it's got something else. What is wrong here? Oh, we have a create account OK and a create transfer OK. So we're expecting a create transfer OK. It's interesting though. This error message looks, it says expected create account OK. So somewhere we're saying create account OK here. Create transfer OK. Transfers. Collect results. Down here. So lots of typo inference going on here. This create account OK is not correct. This is create transfer OK. Okay, so now we should have mostly, all right, here's another thing. I was going to say we should have mostly conversion, missing conversion impls, but here's something else that is different. Expected function pointer found closure. Okay, so this is interesting. The collect results is expecting us to return and not expecting us to pass a function that it can run to do this little comparison. And not a closure, just a raw function with no state. And I've written here a closure, but in Rust, a closure syntax will be coerced to the underlying function type if it's not a closure that has any captures. But here I've apparently written a closure that does have a capture somehow. And it's interpreting this as a closure, not a raw function, which is kind of surprising. This is hard to debug too, because look at this garbage. That is very hard to read. It expects a function pointer. So this is a raw function pointer. But we have a closure. And actually, I think this is probably a little bit misleading. I think this error is a little misleading. The problem is not that it has a closure. It's that this closure has the wrong type. Because if we look at the arguments here, it's expecting a create transfer result reference in the closure as one of the closure arguments, but it's seeing a create transfers result T closure arguments. So again, I probably got the type inference wrong somehow by just screwing things up in some way or another. So let's see again here. And this might be fallout from not having the right conversion impls available, because it might be doing type inference based on the conversion impls. So this might go away if I implement the conversion traits. But let's look real quick just to make sure there's nothing obvious. So this argument is result is for event, and this is a function that takes a C result, which is a type parameter, and a C event. And this looks like it takes a C result and a C event, TB transfer T, TB transfer OK. And message is a completion message of C event. I might have gotten that completion message type wrong, though it's also probably being inferred up here. Create packet is probably creating that type right here, because this is our completion message channel. This doesn't really look wrong to me. C event, C result here. And again, it's the C result type. So this is the C result type, and the compiler is seeing the wrong type here for some reason. If we look at the implementation of collect, I'm not going to go through this for long, because I don't know if this is very hard to just intuit what the compiler is seeing in this case. The compiler is seeing the wrong type for this type. So if we look at how it's using it, we're passing this next result. And the next results are non-empty result. I'm wondering if I got this wrong, and this is actually not the C result type being passed here, but the Rust result type being passed. Result accumulator is containing a Rust result wrapper. Result, here's we convert the result to a Rust type. I'm really doubting myself about. I'm going to go look at the previous submit create account. This is the one that works. Yeah, and this is also passing the Rust result, the C result type. This is the Rust is for event is the thing being called. So this next result underscore should be a C result type. Okay, and here's we're doing the conversion. Okay, so this is the C result up here. We're iterating over the C inputs and the C results. And then if we find the C result that is correct, we do a conversion to the Rust result right here. So for some reason, this is being inferred as a different type. I'm guessing that it's because this conversion method doesn't exist. So the conversion trait it's resolving here is like convert, it's just for every type. It's the convert the self type into its self type. And so the inference here is saying, well, I'm converting this Rust type into a Rust type because the actual conversion method doesn't exist. So I'm hypothesizing that if we implement those conversion traits, everything will type check correctly. Dangers of type inference. Oftentimes you need to write a bunch of code with lots of type annotations in order to get it all to work, and then you can remove the type annotations so that it looks pretty. But if you make any little tweaks to it, then the inference all fails, and it gets hard to understand what's going on with all the type inference. Anyway, I need to implement these two conversions. I'm just thinking right now about what order I want to implement them in. I think I'm just going to implement them in this order again. Put down here. And all this stuff I don't need, but I'm going to have a similar pattern. And this is going to be a to-do, And this we're probably going to need something like that. All this stuff is going to be a to-do. All this is going to be a to-do. So we're going to get our method signatures right and then go fill them out, as we usually do. So we need to implement a conversion from create transfers result to create transfer result. Create transfers result to create transfer result. And again, we'll fill this all in later. We're just going to type check this, and then we'll fill it in. And we need to convert from TB transfer. And we're just converting between C types and Rust types. And this is, okay, so this is just bidirectional. Convert from C type to Rust type or Rust type to C type. Transfer TB, transfer T, transfer TB, transfer T. Okay, and I think there's one thing we're missing here, which is an enum for create transfer result. We haven't defined that yet. So somewhere up here, there it is right there. So we have it defined, but we haven't actually put all the variants in here. So the next 20 minutes or so are going to be pretty boring. We're just going to be transcribing C names into Rust names and vice versa. So I'm going to refresh myself real quick. Oh, it's going to be boring. But I'll talk through it and try to be, conversational and calm. We need to find create transfer result, probably in our Rust bindings, called create. There's create transfer as result. And there's a C enum called transfer. There it is right there. Create transfer result. And it looks like these are probably all the definitions we need. And I think I'm going to, real quick, this is called create transfer result over on the left, create transfer result. These look like results for creating a transfer. So we're going to go copy all these names as their C definitions and just deal with all of this stuff. Oh, this is so gnarly. Okay, so we can do some search and replace to get rid of some of the garbage here. Replace string pub const with nothing. And TB account result. Oh yeah, all these TB account results. I can do some string replacement to get rid of that. And in fact, I don't know if string replacement here is actually going to get us there, because I just need these to all be formatted like Rust, in the Rust style as what are these called, like not snake case, camel case. And these are so far off from the Rust naming, I'm just going to have to write them all by hand. So let's do this a different way. I wonder if we can find these formatted somewhere that looks a lot better than in the Rust binding. This is really tough to read on the right-hand side of my screen. So let's back off and try this a different approach. All right, in the right-hand side, let's get tbclient.c. Maybe it'll be, or .h. Maybe it'll be formatted better here. Create. Yeah, that's so much easier to read. And again, somebody more savvy in Emacs could probably automatically convert these, but that's not me. I'm just going to write them all by hand. But what I'm going to do, actually, I am going to copy them over there. Easier to read them when they're right on top of each other. Let's do a little replacement, actually. let's get rid of that TB create transfer underscore TB and replace TB create transfer underscore with nothing. So these are the names I need, but I need them to look like Rust names. So I'm going to write them by hand. And notice here, I don't have an OK variant here. The okayness is accounted for in a different structure in my Rust bindings. So there's kind of some trade-offs here, like whether I keep this looking like the underlying C data structures or make it look more like I think will be ergonomic for Rust. But right now I don't have the success case in this enum the way the C code does. So no OK, but everything else we keep. Linked, event, failed. Linked, event, chain, open. Imported event. And I'm gonna try to read this as, calmly as I can. Make this as enjoyable as I can while it's boring. Timestamp must be 0. Imported event timestamp out of range. Maybe if I read them carefully, I'll think about them. Imported event timestamp must not advance. And maybe by thinking about them, I'll gain some insight. Reserved flag. ID must not be 0. Oh, that's good to know. IDs can't be 0. I was wondering that, several weeks ago, whether zeros were valid IDs. ID must not be int max. Exists with different flags. Exists with different pending ID. Exists with different timeout. Exists with different debit account ID. Exists with different credit account ID. All these exists with suggest to me that it's okay to call create transfer twice for the same transfer, as long as they have similar fields, as long as the fields don't change. That's kind of interesting. You can create the same transfer twice. Maybe you can update a transfer in some ways with different amount. Exists with different user data 128. Exists with different user data 64. Exists with different user data 32. Exists with different ledger. Exists with different code. Exists. ID already failed. Flags are mutually exclusive. Definitely going to have some typos here, but no big deal. Debit account ID must not be 0. Debit account ID must not be int max. Credit account ID must not be 0. Credit account ID must not be int max. Again, if you're just joining us, I'm so sorry. We're doing very boring stuff right now, but I'm trying to make it as pleasant as possible. It's going to go on for the next 10 minutes or so, just typing stuff. Pending ID must be 0. Pending ID must not be 0. Okay, interesting. Pending ID must not be int max. Pending ID must be different. Timeout reserved for pending transfer. Closing transfer must be pending. Amount must not be 0. Ledger must not be 0. Code must not be 0. Debit account not found. Credit account not found. Oh my gosh, how many of these are there? 55. Accounts must have the same ledger. Transfer must have the same ledger as accounts. Pending transfer not found. Pending transfer not pending. Pending transfer has different debit account ID. Pending transfer has different credit account ID. Pending transfer has different ledger. Pending transfer has different code. Exceeds pending transfer amount. Oops. Pending transfer has different amount. Pending transfer already posted. Pending transfer already voided. Pending transfer expired. Imported event timestamp must not regress. Imported event timestamp must postdate debit account. Imported event timestamp must postdate credit account. Imported event timeout must be 0. Debit account already closed. Credit account already closed. Overflows, debits pending. Overflows, credits pending. Overflows, debits posted. Overflows, credits posted. Overflows, debits. Overflows, credits. Overflows, timeout. Exceeds credits. Exceeds debits. Okay. Now, if you're like me, you're probably thinking like, wow, that was a lot of really fiddly, error-prone data entry. And I totally agree. Like, almost certainly I typoed something there. And in the future, the C definitions of create transfer result will change. Like, there will be variants added. So it's a very brittle code, lots of potential for errors. But this is also pretty easy code to test. So at some point, we're going to write we haven't written any unit tests now, but at some point we'll write a unit test that just mechanically reads the C definition here and then does like a round trip test to say like, okay, for every possible C definition, there is a Rust definition in the interconvertible. And that's kind of like a bread and butter type of test. So it's easy to add unit tests that make it future-proof. But also, we've adopted a pattern here where if we see a C enum that we don't know, we will create an unknown variant on the Rust side. And once we have those unit tests in place that are exhaustive, we won't need this variant anymore. So question in chat, what are we doing? So my name is Brian, and I'm working on the Rust bindings for Tiger Beetle. Tiger Beetle is a financial database written in Zig, very high performance, and it has clients for Python, Java, Go, JavaScript, and I'm working on the client for Rust. This Rust client is actually bindings to a Zig library called tbclient that exposes a CFFI. So we're creating like a idiomatic Rust API on top of the CFFI to talk to the Zig database, the Tiger Beetle database. We've been working on this for maybe 2 months now on stream, doing the whole thing on stream. So eventually I'll also upload the entire series to YouTube so you can watch the entire creation of this Rust project from front to back. It's a nice little bite-sized project. I'm doing the whole thing as kind of an instructional exercise in public speaking and streaming. It's the kind of the first thing I've ever streamed. And today, we're kind of just implementing more requests. So we spent weeks now kind of understanding how to implement a Tiger Beetle request in Rust in a idiomatic Rust way. And we've developed a pattern there, and we've extracted out some generic helper functions. So now actually implementing all the requests is mostly just a matter of following those same patterns for another 6 times or so. So it should be pretty straightforward, but of course, we're, talking our way through it, so it's not super fast, but, this next few episodes should just be a matter of kind of redoing the work we've already done with slight changes to the types involved. Yeah, Mr. Oleg's Tiger Beetle is pretty interesting for its technical leadership. It's kind of one of the assets of Tiger Beetle, I think. The way that they have kind of developed a new database from first principles for a very niche domain, and doing it like using all the best practices from the last 10 or 20 years in database design. It's a pretty neat little, very compact piece of software. Pretty exciting stuff. And some of the people at Tiger Beetle are very smart. Like if you know Matt Cladd, the Rust genius, the guy that wrote Rust Analyzer, and he blogs a lot and he streams on this channel, Zig-related stuff. He's very smart, and some of the other people at Tiger Beetle are also very smart and know a whole lot more than I do about databases and compilers and programming. So that's the one thing. One of the things that excites me about Tiger Beetle is just the technical excellence and technical leadership and the opportunity to show our work. That's one of the things I really look for in a company, actually, is companies that are kind of demonstrating their engineering and showing technical leadership. That always makes me very encouraged. A lot of companies will start off being like small startups on Hacker News, and they'll kind of be showing their engineering and showing what they're about. And then, as time goes on, it's less about engineering and just more about the business. And Tiger Beetle, at least, is in a phase where it's showing a lot of cool technical stuff. And also one of the leaders in Zig. A lot of opportunities in the future for Tiger Beetle to show Zig leadership and, teach people how to Zig. That's not me at the moment. I'm rusting, but at some point after this project, we'll do a Zig project on stream. Anyway, I got to keep plowing on through these conversion functions. So right now we've kind of rewritten the create transfer result enum in Rust from C. And these are for the actual surface level Rust API. So I'm writing them by hand so they look exactly the way I want and so that they're readable. Let's make sure this builds still. And it won't, it should build. This should type check. And again, if you've noticed, I've been streaming here for an hour, it looks like. And I essentially, since we started, I haven't run the build at all. I've just done the type checker. And that's pretty much how it always goes in Rust. You spend a lot of time type checking, and then you run a cursory test for a while to make sure it actually works. But we're just type checking now. And all right, type checking is good right now. So we have these 3 methods that are 3 conversion functions. And again, for those just joining us, I'll show you what we've done here. Today, we have implemented this create transfer request method. It's an async method. And based on the patterns we've developed over the last few streams, it's just calling these 2 generic methods, create packet and collect results, that are doing all the heavy lifting. So we just had to plug in, a few types here. Here's some type annotations, this particular operation enum, and some more conversion functions and types down here. But for the most part, we just plugged in some types and the generic functions inferred everything and did the right thing. But this generic function that we have, I'll show you the big one, collect results here. Nasty to look at these types. But it's readable if you know Rust and you read it intently. You can kind of understand what these types mean. But these all depend on, conversion functions to exist, or conversion trait implementations. This one too, create packet. generic function depends on this conversion. So that's what we're implementing down here. But these aren't implemented correctly, so we got to go make that happen. And again, we're just going to like look at what we did previously. Oh, I'm not looking forward to this. So we got to do, this basic thing, but for all these transfer results. So this function is converting from the C create accounts result to the Rust create accounts result. And you might ask yourself, like, is there an automatic way we could do this? There are, but I don't want to do that in this case for reasons. Like, we could make our enum bit compatible with the C enum and just cast them unsafely to each other. And there's a few other things we can do. But I like the API, the Surface API, to be handwritten for the most part. This looks cleaner and looks exactly the way I want it to. So down here, we need to go look at create transfer result, okay? And go to all these cases and plug them in here. And this isn't going to be too bad. And we've already imported the Rust variants, so each of these cases is going to yield one of these Rust variants. And this looks... Oh, these all need to be prefixed, I think, with the module name that they're in. So up here, oh no, we're importing everything from the TBC module. These all live in the TBC module. So these are all named correctly. And I'm going to go ahead and fill in this catch-all case. And again, if we had stronger testing, we wouldn't need the catch-all case. But if somebody ever adds another variant here without better testing, the Rust code doesn't know about that variant. And that is also why I marked this enum as non-exhaustive. So this says that pretend like I don't know all the variants of this enum. And that means, like, normally Rust will say, if you match on an enum, it'll say you got to cover every single case of that enum. But if you say, no, this enum is not exhaustive, then it'll allow you to not match every case of the enum. And that means that we can add more variants here in the future without breaking this API. And that's important to us because we're expecting this to change a lot as Tiger Beetle is developed and evolves. All right, so let's stop digressing and let's get to typing, y'all. All right, so this is going to create. Oh, this case is not reachable because remember, for our Rust variant, the OK case is covered by a different data structure. So we're never going to hit this case. And before we just said unreachable. So that's what we're going to say in this one too. Create transfer OK is unreachable. And this unreachable macro in Rust says that I don't think this case will be reachable. It's not like strong unreachable in the compiler sense where like this branch is impossible. Like in, I think Zig, if you say this is unreachable, in the compilers generally, if you say a branch is unreachable, you're hinting to the compiler like this will never ever happen. But this macro was created very early on in Rust's lifetime because it made semantic sense from a user perspective. But I think it's kind of unfortunately named these days because it sounds stronger than it is. Anyway, let's keep going. Linked event failed. All right, we're going to do the same thing again, y'all. I'm just going to talk gently and type fervently. Linked event chain open. Imported event expected. Imported event not expected. Timestamp. Timestamp must be 0. Imported event timestamp out of range. Imported event timestamp must not advance. Fat arrows. Thanks, Future Highway. I'm feeling deja vu right now. The syntax is incorrect because these need to be fat arrows in the match arms. Thanks for the help, chat. Yep, I did exactly the same thing last time. Fat arrow, reserved flag. ID must not be 0. ID must not be int max. exists with different flags, exists with different pending ID, exists with different timeout, exists with different debit account ID, exists with different credit account ID. Ugh. I know this is kind of easy. Like this is the easy stuff today, but it is taking time. I think we have 6 more of these to implement, something like that. And this has taken about an hour so far. Not bad, considering we're streaming especially. And, not taxing on the brain, which I value on a Christmas Eve. But it is taking quite a while. All right, give me literally 5 seconds and I'll continue. What up? Let's keep going. Stream's looking good. The orange backlights. Sun's gone down, so the sun's not shining. My lighting's looking good. Pretty happy. Oh, my flare is not so good looking anymore. I'm practicing like accessorizing on stream just to create some visual interest. So I'm experimenting with bandanas. Whatever. Okay, back to the grind. All right, again, we are just creating these conversion functions, mindless typing. Exists with, and make sure my scene is correct, you can see what I'm seeing. Exists with different amount, fat arrows, don't forget the fat arrows, exists different user data 128, exists with different user data 64, with different user data 32, exists with different ledger, fat arrow, exists with different code, fat arrow, exists, ID already failed, fat arrow, flags are mutually exclusive, fat arrow, debit account ID must not be 0, debit account ID must not be int max, credit account ID must not be 0, credit account ID must not be int max, fat arrow, accounts must be different, pending ID must be 0, pending ID must not be 0, fat arrow, pending ID must not be int max, pending ID must be different, timeout reserved for pending transfer, closing transfer must be pending, amount must not be 0, ledger must not be 0, code must not be 0, debit account not found, credit account not found, accounts must have the same ledger, transfer must have the same ledger as accounts, pending transfer not found, pending transfer, not pending. Fat arrow, pending transfer. Transfer has different debit account ID. Pending transfer has different credit account ID. Fat arrow. Pending transfer has different ledger. Pending transfer has different code. Fat arrow. Exceeds pending transfer amount. So much more to go. Pending transfer has different amount. Pending transfer already posted. Pending transfer already void. I'm making more and more typos. Voided. Pending transfer expired. Imported event timestamp must not regress. Imported event timestamp must post date debit account. Ooh. Imported event timestamp must post date credit account. Imported event timeout must be 0. Debit account already closed. Credit account already closed. Overflows debit pending. Overflows credits pending. Overflows debits posted. Overflows credits posted. Overflows debits. Overflows credits. Overflows timeout. Exceeds credits. Exceeds debits. All right, done. Now let's see if we made any mistakes. Yep, missed a fat arrow. 597. Fix that fat arrow. And what else? Okay. A unit, credit account not found. A unit variant with a similar name exists. Credit account not found. I wonder if I didn't. Something must be okay. Let's fix the first error. This syntax error might fix all that fallout there. 603. Missed a comma. Yep, still a bunch of resolution failures. Why is that? Overflows, debits, debit pending. Similar named unit variant here. Wow, these are all typos. Debit account ID must not be int max. Debut, okay, there's lots of typos. Let's go fix all these typos. All right, the first one is debut account is wrong, so 281. Line 280. 281, it says line 281. Oh, 281. Yeah, there it is. Debit. All right, what's the next one? Credit account not found. Credit 1C. 621. Nice thing about doing these bidirectional conversions all by hand is that I can at least get the typo checking here. Cannot find value. Accounts must have the same ledger. Accounts, okay, yep. Lowercase m there, 296. And overflows debits pending. Overflows debit pending. Okay. Singular where it should be plural on 641. Let's see if that checks. Expected create. Okay, yeah. This can just be, doesn't have to be prefix, just unknown. Likewise up here, this can just be unknown. Check that. Okay, this is gnarly. This is gnarly. So I've done something wrong here. And what I've done wrong is the Rust bindings name these variables. So these are all essentially enum variants in C, but in the bindings, they're actually just standalone constants. But those Rust bindings, for disambiguation reasons, has given these different names than the C bindings. So the C code calls it TB create transfer exceeds credits. And I did this exact same thing last time we did this, but the Rust code calls it something different. So let's look at the tbclient.rs. And again, what's going on here is this match arm. I have attempted to match this variant, but actually what's happening is, and this warning is actually quite misleading. The compiler thinks I've tried to create a variable binding called TB create transfer overflows debits. Like there's this ambiguity in the semantics where it's like this thing here could be matching a constant, or it could be introducing a named variable, a binding. And in the absence of resolving this to a constant, the compiler says, okay, well, it must be a variable. So this is saying, well, you're creating a variable, but you've named it very strangely with all these caps. It doesn't realize that this, should be matching to a constant. But, there's a common enough ambiguity in Rust that, it's pretty easy to recognize instantly what's going on here. I've typoed every single one of these bindings, or constants. So let's go look for, they're right here in the Rust code. I'll bring these up to the top of the screen. You can see these are called TB create account result. Wait, TB create transfer. TB create transfer something, right? But in the Rust code, all these constants are prefixed with the C enum name. So it's TB create account result, TB create account something. So basically I need to have TB create account result prepended to all of these. Fortunately, we can do that with some string replacement. So let's go up here and say replace string TB create underscore with TB create account result underscore TB create underscore. And those should be the right names. Nope, I still didn't do it correctly. What did I miss here? TB create account result TB create. That looks right to me. 648. It's saying it's not right. So we're importing these names. TB create account result TB create account. Oh, shoot, chat. These aren't accounts, these are transfers. So let's go TB, do another string replacement, and say replace string TB create account with TB create transfer. There we go. Those should be the right names. Yep. Thanks, Brongulus. All right, so now all that checks. And again, we don't care whether it works or not, but now that we've type checked, it's probably all more or less correct. And again, someday in the future, we'll write a comprehensive unit test that just guarantees this is all definitely correct. We got two more of these bad boys to deal with still. So let's go look at the patterns we had on the old code. These are just simple struct conversion. This is easy. So we can go find our, because the Rust structs have the exact same fields as the C structs. We're just kind of redefining them to give them Rust names and Rust representation. So let's go look at our transfer struct and just copy all this. So here, these are going both ways, but these are almost the same function, just with different struct names. So we're going to say, so from the TB transfer T, we're getting a transfer. And we can get rid of these comments and these pubs. And just checking, I'm always forgetting the syntax for field initialization. It's colons. In Rust, usually the type declaration and type initialization and value initialization have the same syntax. They're mirrored for simplicity. But some languages, like you'll have like a colon for defining a field and an equal sign for initializing a field. And I'm just always forgetting. But this is just going to be other.id, other.debit account ID, other.credit account ID, other.amount. And again, all this typing is error prone, but eventually we'll create some test cases that do round trip testing so that both representations that are isomorphic are guaranteed to be identical. Other.user data 128, other.user data 64, other.user data 32, other.timeout, other.ledger, other.code, other.flags, other.timestamp. Let's check that. Check. And that type checks. We can do the exact same thing in the other function. It's just going the other direction. And we're going to say tbc tb transfer t. In Zig has like anonymous struct initialization. You could probably just like say, like here's a bunch of fields, just figure it out, cast that anonymous struct to the name struct. Probably. I don't know. I'm not that familiar with Zig, which is kind of a neat little thing. Zig often feels like very dynamic, even though it's completely static. It often feels kind of like writing JavaScript. There's a lot of duck typing and a lot of things that feel like duck typing, where you can have like, structural types being automatically coerced to name types and things like that. The feeling of programming in Zig feels very dynamic. Anyway, this is Rust. TB transfer T, that should also type check. Great. So we finished the implementation. Again, that was like hour and a half almost, just filling out all this code. And now we get to actually run it and see if it doesn't crash. So here's our code for creating accounts. And I think I'm going to leave all this in place. Actually, I'll bump all this out to like a separate test. This isn't the test. It's just like test code. And I'm going to call this async fun test accounts result. Just so I can leave it around here and it does something useful. And then I'm going to copy and paste it and just use it for testing transfers too. I'm going to say test transfers and call this function test transfers. And for test transfers, we're going to need accounts, but we already have some in the database. I'm going to call this transfer ID 1, transfer ID 2. And we're going to need to look at our transfer data structure. And remember that we have accounts 21 and 22 to use. Accounts 21, 22. Those are already in the database because we've already run the account testing code and we've got a test database already initialized and just sitting around. And so we're going to create a transfer, and we'll start by just creating one transfer. And I don't actually really know much about the semantics of transfers, so I'm just going to be kind of guessing what all these fields do. Most of them we probably won't need. So we'll have an ID for the transfer, and I assume we make our own IDs here. For accounts, you make your own IDs. Maybe transfers get assigned IDs. We'll find out. Debits pending. Wait a minute. Okay, these fields are all wrong. Let's copy the fields from the transfer struct. And again, we'll just string replace these pubs out of there. So with debit account ID, it's going to be 21. And I'll make constants for these two because this code is probably going to hang around for a while. Account ID 1 equals 21. Let account ID 2 equals 22. So we'll call this account ID 1, account ID 2. Amount, we'll say 1. Pending ID, don't know what that means. We'll hope 0 is allowed. User data, just zeros. Timeout, don't know what that's for, but I'm going to put a big number here. Ledger, ledger is 5. You already have a variable defined for that. Code is code. We have a variable defined for that. Let's assume we can have 0 for flags, and I think timestamp is filled in by the server. Again, I don't really know what the timestamp's role is. So this should create a transfer. And then down here, we haven't implemented lookup transfer yet. So I'll just say submit transfer lookup. And I'm just going to comment out this code. Transfer ID 1, transfer ID 2, and we'll just comment this out. And let's see if this does something. Say, now we're going to finally run all that code we've been writing for so long. I have a typo. This, like that. Probably one there too. Yep. And it doesn't really matter to me what the result of this code is, as long as it looks like it's some sensible result from the server. Let's see. Oh, I need to await. This is an async function, and this is returning a future, so I need the result of that future, so I need to await for it. Run. Okay, and it ran, and it said timeout reserved for pending. Okay, so that answers a little bit of our questions about what timeouts are for, but apparently I'm not supposed to use the timeout here. Timeout is for pending transfer, so you can kind of use your imagination to understand like what a pending transfer might be. I don't know, but we could guess. But timeout should be 0 apparently. And then we went to the server and it was a success. The server over here, not really logging anything very interesting, but that code worked. So we spent 90 minutes writing that Rust code, which was not terribly difficult because of all the groundwork we've done the last few streams, but it just worked. You know, that's the way it goes. All right, let's took 90 minutes to do that one method. I kind of want to do the transfer now too, but let's go back and look at the library real quick. Like all of these conversions, these are just noise, right? This is code that is very uninteresting, and it's not going to be maintained except mechanically. Like the way this is going to be maintained in the future, like reading it is boring, uninteresting. And maintaining it is basically going to be like, we're going to have unit tests that automatically detect like, oh, the underlying C enums have changed. So the unit tests so these conversion functions are now broken. And the unit test should just automatically tell maintainers like, you know, these conversions are no longer correct because I exhaustively tested them. And so they're going to go in and they're going to, you know, mechanically look at, okay, there's a new one of these, so we need a case for all these. So, and again, we have like 5 or 6 more of these requests to write. They're just going to keep accumulating these conversion functions. So I'm going to bury these. I'm going to create a whole module just to hide these conversion implementations called mod conversions, and say conversions.rs, XO, and let's just take all of this visual garbage and throw it over here. And now we're probably going to need some imports because we've taken some of these, don't have any more imports in our conversions method. And also, these are trait implementations. So like none of this stuff ever has to be in scope anywhere. These are just implementations of traits. So you never have to import anything from these modules. This module just exists to contain these definitions, which are trait implementations, and trait implementations just kind of exist in the ether. They're not nameable. Well, they're kind of nameable, but you don't ever import a trait implementation. Hey, Cargo Moon, glad to see you back. We're making serious progress on this project. I don't think we're going to get like to a PR point this year, but we really got some momentum now. Just got to fill out all these requests, and I'm just complaining about how much boilerplate I'm writing by hand. But anyway, I'm kind of burying all this boilerplate in another module right now. So this module doesn't even have to be public. We never have to import anything from this module. It just exists to hold these definitions. Now let's make them all compile. We're going to need probably this TBC module. So we're going to say use super TB client as TBC. And we're going to say, honestly, I can probably just say use superstar. Like this module is kind of just a extension of the main module. Just kind of like pull everything in, but hide it in a different file. So we can probably just pull in all the definitions from the parent module. Kind of sloppy, but in this case, I feel pretty good about it. Let's see if that checks though. And it does. These warnings are all in our main, test program. I can go put a allow unused on main too. That's fine. I am a big fan of allowing unused variables. Shots fired. I wouldn't check it in. I mean, I would check it in, but I wouldn't submit it as a PR. I wouldn't merge it into master like that. But when you're doing a lot of development, exploratory development, just hide all those warnings. Go figure them out later. Okay, so yeah, easy peasy. We just moved all these. Rust is great for refactoring. Like most typical refactoring actions are pretty easy in Rust, especially because Rust has things like re-exporting. Like you can take a bunch of definitions, move them to another module, and just suck in definitions from whatever modules you need. You can have this use here. I can say pub use to just re-expose the same definitions in another place. Rust is pretty great for code motion. And a few weeks ago, I remember reading some rant on Hacker News where someone was complaining how terrible Rust is for refactoring. And I was just like, no, let me correct you. Only time I comment on Hacker News is when I'm angry at this point, I think. It's bad. It's so bad. I'm not very constructive on social media. What am I doing? I'm screwing things up at this point. Okay, all that builds. Let's run one more time. Yeah, okay. Everything's still working. All right. I think I'm just going to take a second to step back and collect my breath, collect my thoughts. That was not too bad. I'm just kind of deciding whether I want to spend another 90 minutes working on the other one. We've implemented. So today we started off with the create account and look up accounts requests. And we would like to have create transfers and look up transfers. We've done create transfers. Don't have look up transfers yet. It took us 90 minutes to do one. It's 5:30. I think we're going to call it tonight, chat. It's kind of probably time I should go cook some dinner for my partner and go chill. But this was very productive. We're going to be doing this pretty much the same thing for at least the next week, probably 2 weeks at the rate we're going. We're kind of getting there, though. We've got a lot of momentum now. We've kind of solved the initial design problems for this project. So we have to implement, maybe 5, 6 more request types, just following the same pattern. It's going to be very chill, just kind of, duplicating code and then filling in those conversion functions and Rust definitions of CE enums, kind of in a very rote manner. And after we've got all those requests implemented, we have to do a few more things. I don't think I'm going to do the test yet. I kind of want to get to a point where we can submit a PR and like make an announcement on the Slack. I think it's Slack. Like, hey, we've got Rust bindings, in tree that you can go try to use. But they won't be production quality, obviously, but have them functional in tree so people can check them out and so that we can show progress toward what we're doing. And I think at that point, I think it probably doesn't really entail having actual tests yet to do that, though I do want to have good tests. I do value testing and want things to be tested. But just to have like a prototype in tree, I don't think we have to have all the tests written. So probably the next thing we're going to do is after we get the requests implemented, but maybe right, I just said we're not going to test. Who knows? We might make a smoke test or two. But the testing for this is going to be interesting in its own right. And it's probably going to take, a number of streams. We're going to probably build up some custom test harness that are fairly sophisticated and, interesting to talk about in the Rust programming sense. What happened to my flare, y'all? Guys, you got to tell me when I screw up my flare. All right. I can tell it's time to call this. My accessories are falling off. But we're probably going to hook up the build system, make sure the build system works as necessary so that both the Tiger Beetle, the Zig side, and the Rust side of the build work together to create this crate. Because right now I have to run like 2 builds. And at least some initial documentation. I don't know if we'll go like full on, like document everything fully. At some point, we'll definitely write some very comprehensive documentation for this Rust API. But after we got those things done, we'll submit a PR and get some review, and the review will probably take a while because people will have opinions. And if you've noticed, like we've been working on this for weeks and weeks now, and I haven't even looked at the other Rust or the other language clients for Tiger Beetle. So I actually don't know like what the style is for developing language clients. I just kind of intuited how I think a Rust language client should work for Tiger Beetle based on my knowledge of Rust and my understanding of Tiger Beetle. But before we submit a PR, we should probably go read the Go client and kind of like validate, the decisions we've made here against the decisions that other Tiger Beetle programmers have made when creating other clients. Because anything that we've done that is way out of step with Tiger style, we're probably going to get slammed immediately on the code review if we aren't aware of the precedent. But pretty soon, in a few weeks, probably not before New Year's, but pretty soon we'll have a PR in. People can test this, and people will be happy in the forums to see that this is available because multiple customers or multiple users have wondered where the Rust clients are, and they'll probably be happy to see that. But I'm guessing it'll take another 2 months maybe to really get this thing to production quality. But after we've got the prototype landed. Anyway, I'm pretty excited about this project, and I'm grateful that people are coming and hanging out and enjoying the stream to the extent that they can. And I appreciate the help, chat. Chat has been super helpful correcting my mistakes and noticing the bugs I'm writing as I'm writing them. Been a very rewarding experience. I hope you come back and see more. I'll catch you all next time.